Thank you very much for the invitation. I'm honored to present my research project at the Moving Images Static Spaces conference. Against the backdrop of the current second wave of virtual reality, this interdisciplinary research project theoretically and artistically deals with adaptive audiovisual architectures. It combines methodologies of media art, design research, architecture, and media theory. Building on the observation that architecture's medial turn has led to the liquefaction of its discipline boundaries, Schäffner 2010, the project investigates IT setups for the real-time generation of augmented experience spaces. This paper presents the framework for an interactive audiovisual AR installation with ambient intelligence. The Immersive Architecture Generator, IAG, allows users to interact and play with architecture as if it were a musical instrument. The IAG visually and orally augments physical architecture and creates immersive environments which can interact with audiences, musicians, or other performers. The novelty of the approach lies in its understanding of architectural spaces as musical instruments, as well as spatial design as a musical activity or task. After explaining the conceptual background of the project, this article gives a high-level overview of the design and the operating principles of the IAG, and goes on to describe 3 use cases of the digital scenography instrument in installation and performance settings. Starting point and inspiration for this project was the perceivable outward projection of digital logic into and onto the physical world, which leads to an increasing gamification of architectural spaces and our perception of them. The understanding of architecture as a rigid, static art form, which is poetically coined in Schelling's famous aphorism, "Architecture is frozen music," is currently undergoing a reframing. Our perception of reality is ever more mediated by information technological processes. Our gaze through the proverbial data glasses, which are factually graspable in the current trend of head-mounted AR and VR displays, invisibly and silently pervades practically every aspect of our lives. IT and its underlying quantification paradigm overlays the physical world with an invisible skin, a grit coating. The boundaries between physical and virtual world also liquefy increasingly in architecture. Augmenting physical architectures with the logic of interactive computer game environments leads to a whole new architectural vocabulary. Concepts like Benham's Anhaus or Negroponte's responsive architecture are becoming an augmented reality. Pun intended. By pointing out 3 phenomena, I'd like to briefly discuss some of the implications of the gamification of architectural space. Reality computing, a term coined by Autodesk in order to strategically position themselves in an emerging market field, describes the projection of physical spaces into virtual spaces and vice versa. Physical architectures get overlaid by virtual content and hereby become screens or digital canvases. Physical spaces get permeated by digital media content, be it robotic production pipelines, films, or computer games. For a couple of years already, the 2 media, film and computer games, are in the process of merging due to the virtualization of production processes, for example in virtual production and previs. Physical perception of space is ousted by virtual worlds unfolding around us. This leads to an interweaving of the analog and digital domain, resulting in a new hybrid analog-digital materiality, perfectly depicted by Matsuda's hypothetical research by design case study, Hyperreality, yet already brought into reality by Google's Project Tango around the same time in 2016. Sesponsivity, a term coined by Ungrinis and Liapis in 2014, in their paper Spatial Elements Imbued with Cognition, a possible step toward the architecture machine, describing the shift from mere reactive behavior of interactive systems to an ambient intelligence which would imbue space with cognitive skills and provide it with a sense of why, how, and when to act. Interactive spatial experience is negotiated between designer, user, and the media technological apparatus. Consequently, interactive medial design becomes an architectural problem. Also, the design authority of architects experiences a shift towards the user and the agency of media technological systems. From a media theoretical point of view, interaction with real-time reactive systems can be understood as musical engagement, or a musical task analogous to playing a musical instrument. In the spirit of Harenberg's and Gossman's understanding of media technological configurations as musical instruments, I propose to apply the term medienmusikalisches Handeln, media musical engagement, towards interactions with adaptive architectures. Based upon these observations, the project investigates three main topics. 1. Interfaces and models of interaction for computer-mediated architectures. Areas of investigation herein are the role of architectural space as interfaces, the complex mesh of relations between designer, media technological apparatus, and the user, and not least the role of ambient intelligence in settings of coactively negotiated design decisions for interactive environments. 2. Sound and time as new dimensions of architectural design. In light of the relevance of time-based design paradigms for medially augmented spaces, the relation of the disciplines architecture and music are investigated, namely interdisciplinary approaches for the design of time, space, and sound. 3. Artistic exploration of AR and VR. Focus here is the investigation of aesthetical qualities of said hybrid analog-digital materiality in augmented reality settings, deploying real-time CGI and real-time sound generation. In order to achieve these, the framework of a generative audiovisual environment was developed, which facilitates the playful interaction with immersive adaptive architectures as a VR as well as an AR application. The system is based on state-of-the-art game engine technology, Unity, has its own agency, and is therefore capable of taking autonomous design decisions. The open and modular conception of the system allows for a multitude of interaction models. Inputs can range from motion detection to video, controller, or sound to raw data. For the exploration of multimodal paradigms and methodologies of interaction, different user groups are observed and analyzed in their interaction with the IAG. Time-based design paradigms for generative architectures are explored in collaboration with musicians, composers, and architects. For this purpose, digital scenographies and dramaturgies for medially orchestrated environments are conceived and realized as live performances, installations, and VR experiences. The system follows a modular design principle from the core. For maximum flexibility, the modules can be used independently of each other, but can also be combined arbitrarily, which allows for the realization of a multitude of diverse use cases. A possible use case could be the visual augmentation of a physical space on the basis of reacting to aural stimuli. Equally possible is the mere sound augmentation of a physical space, which might be based on visual or other data input. Obviously, the combination, the audiovisual augmentation of a physical space, is also possible. The installation is comprised of sensors and controllers, a real-time video processing unit, a real-time audio processing unit, a multi-channel video projection setup or a head-mounted display, as well as a multi-channel speaker setup or headphones. As controllers, multimodal input devices like the HTC Vive controllers or MIDI controllers are used. Deployed sensors currently range from, but are not limited to, cameras, microphones, depth, or motion tracking sensors. The real-time video processing unit is comprised of one or an array of computers, off-the-shelf real-time video processing software like Unity or Max MSP, open source software, and self-developed software. The real-time audio processing unit is comprised of one or an array of computers, off-the-shelf real-time audio processing software like Max MSP or Ableton Live, open source software, and self-developed software. The sensors and controllers gather data on users' action and behavior, for example, users' movement in space. Real-time audio and video softwares process these data and feed them either directly into certain parameters of the audiovisual design or gauge the data semantically by means of computer vision and computer listening analysis. These metadata on users and their behavior, for example, the activation degree of a crowd or the tonal qualities of a musical performance, etc., also get fed into controlling certain parametric design decisions. The IAG is capable of translating the gathered data autonomously into visualizations and oralizations. Models for IAG's autonomous behavior range from basic randomization functions to complex AI-based models. More on that in the use cases. The amount of IAG's autonomy in design decisions is seamlessly adjustable by the designer. Granular control over the design parameters can also be granted to the user. The real-time rendered CGI are projected onto the physical architecture of a space. Ideally, they cover the room in its entirety and therefore unfold a virtual space around the user. This can be realized by deploying multi-channel projection setups, AR HMDs, or VR HMDs. The real-time rendered sounds are played back through a multi-channel speaker setup and therefore unfold a virtual sound space around the user. In VR use cases, surround sound earphones are imaginable. For the exhibition, Imaging and Interaction, Virtual Architectures in 2017, the IAG was played in an AR performance of the Kairos Theory Trio, augmenting the architecture of the shared central library of the Technical University and the University of the Arts, Berlin. Kairos Theory Trio played two 20-minute-long electroacoustical live improvisations. Alberto De Campo and Hannes Hölzel played live surround audio and electronics. Alexander Peterhaensel played the IAG and drums. The digital scenographies for the performance were designed by the author and controlled by aleatoric design decisions of the IAG and by controller input. At the 2018 edition of Crescendo, the yearly classical music festival at the University of the Arts Berlin, a site-specific interactive AR installation on the basis of the IAG is presented. Situated in the auditorium of UDK's Media House, the installation is played in two performances, translating music into an immersive environment. The audio layer consists of a live performance by Trio Ambra, performing Haydn's Piano Trio No. 43, Henz's Kammersonate, and Hosokawa's Memory. The visual layer consists of three interactive digital scenographies designed by the author. During the performances, the immersive environment is driven by design decisions of the IAG, based on qualitative sound analysis and aleatoric processes. For this, each of the musician's instruments is individually mic'd. Therefore, each instrument can be mapped onto specific design parameters of the environment. The acoustic signals simultaneously undergo different qualitative sound analyses. For rhythmical analysis, the open-source IBT module by Oliveira et al. 2012 is used. For sound pattern recognition, the open-source deep learning module Wakinator by Fiebrink et al. 2009 is used. Before and after the concerts, the environment is controlled by the activity level of the crowd as well as aleatoric design decisions of the IAG. The system improvises over a digital scenography by the author, taking into account certain observations about the spectator's behavior and thus creates unforeseen lighting scenes for the augmented environment. This sense-sponsiveness of the environment is attained by a semantical analysis of the room acoustics, which allow for conclusions on the crowd's degree of excitation or commotion. This functionality is facilitated by a use case-specific implementation of the open-source IBT module by Oliveira et al. 2012. Next steps of the research project are, amongst others, experimentation with other sensors and combination patterns of different sensors, the implementation of more complex AI systems for semantic analysis of user inputs, or the translation of the Crescendo performance into a VR experience. This paper introduced the Immersive Architecture Generator, a system for the realization of interactive digital scenographies, its design and functioning principles, as well as 3 example use cases. Furthermore, I have presented the project's motivation and conceptual background. I'd like to thank the University of the Arts Berlin, the Crescendo Music Festival, Professor Anders, Professor De Campo, Hannes Hölzel, Julian Netzer, Christopher Höhn, Roman Gebhardt, and the Trio Ambra for support and suggestions. To round things up, I'd like to finish with a quote by architect and theoretician Markus Nowak, who wrote in 1991, during the first big wave of VR, A liquid architecture in cyberspace is clearly a dematerialized architecture. It is an architecture that is no longer satisfied with only space and form and light and all the aspects of the real world. It is an architecture of fluctuating relations between abstract elements. It is an architecture that tends to music. It seems to me as if architecture was currently defrosting. Thank you very much for your attention.